All right, welcome everyone to this explainer. Look, if you're working with data in Python, you already know that moving information from point A to point B isn't just some basic everyday chore. Honestly, it's the very foundation of your entire system. So today, we're going to take an upbeat, highly authoritative look at how to actually architect robust Python data pipelines from the absolute ground up. We aren't just writing scripts here. We are engineering true solutions. Let's get into it. So let's quickly run through our agenda. Think of this explainer as the architect's journey. We're going to move logically through 5 distinct phases, starting with the high-level blueprint, diving into foundational file operations and arrays, exploring pandas as our universal router, bridging data into storage and publication, and finally, synthesizing the whole thing into one master automated pipeline. Starting right at the top with Section 1, the high-level blueprint, we're architecting the data flow. Now, what's really fascinating about this high-level blueprint is exactly how it visualizes the complete data lifecycle. Look at the progression here. We start way over on the left with these chaotic, totally unstructured raw files. Then, through careful engineering, we actually transform those scattered blocks and cylinders into highly structured data matrices right in the center. And finally, on the right, we export them out as polished, professional final publications, like a beautifully formatted PDF. It's a highly deliberate journey, taking us straight from chaos to clarity. But to build this properly, you have to precisely match your ingestion engine to the specific data format you're dealing with. Notice these 5 distinct phases mapping perfectly to distinct Python tools. Foundation uses native Python for raw text. Arrays use NumPy for numerical data. Tabular relies on pandas acting as the router. Persistent storage uses SQL Alchemy to hit your external databases. And publication utilizes PDFKit and Matplotlib. I mean, using the wrong tool for the wrong phase is literally like trying to hammer a nail with a screwdriver. It just doesn't work. Moving on to Section 2, Foundation and Arrays. Let's talk about managing raw and binary data. Okay, look at how the with open context manager acts as a vital safeguard here. In native Python, why do we bother using this specific syntax instead of just manually opening and closing our files? Well, because the context manager automatically handles all your resource cleanup behind the scenes. It completely eliminates the need to manually invoke file.close, which means even if your script completely crashes halfway through, your system memory stays protected and you totally prevent file corruption. And before we even think about touching more complex libraries, we have to strictly define our state modes. You can see them listed right here. R for reading, W for writing and overwriting, A for appending, and X for exclusively creating a new file. Understanding this is absolutely non-negotiable. You have to ensure you never accidentally overwrite critical raw data. Seriously, if you use a W when you actually meant an A, boom, your historical data is just gone instantly. Now, let's see how this builds into numerical data with the NumPy vaults. Notice the architectural difference between a standard save, an archive save, and a compressed archive. While saving a single array as a standard uncompressed .npy file is totally fine for quick tasks, leveraging the saves_as_compressed module actually packs multiple arrays into a single .npc dictionary while automatically applying zip compression. This significantly reduces your disk footprint for massive high-dimensional arrays, which just optimizes your storage architecture beautifully. All right, Section 3, the pandas router. Time for universal tabular data processing. So the crucial takeaway here is that pandas acts as our universal tabular router. It is absolutely not just for CSVs. Pandas seamlessly ingests everything from live HTML markup on the web to deeply nested JSON files to standard Python dictionaries, and incredibly, even delimited text sitting right there on your OS clipboard using read_clipboard. All these totally distinct environments are routed directly into one unified structured data frame right at the center of your operations. You know, a lot of tech explainers tend to gloss over the harsh reality of messy data, but take a look at this anatomy of a CSV import. This demonstrates true precision parsing. We aren't just blindly loading a file, we're explicitly using syntax to skip junk text rows at the top with skip rows, skipping junk footers at the bottom, explicitly defining our headers, and actively translating those ambiguous double dashes into proper mathematical NaN values right upon ingestion. That is exactly how you architect a clean data entry point. Conversely, when we're finally ready to export that tabular data, look at the discipline required. Why do we explicitly use parameters like index equals false or header equals false? Well, by default, Pandas really wants to write its own internal row numbers straight to your disk. By passing these parameters, we strip out that internal pandas metadata, which completely prevents arbitrary row numbers from polluting your downstream handoff. It generates a perfectly clean output file every single time.
And check out how we handle Excel architecture here. A standard basic export to Excel will just brutally overwrite an existing file. But by utilizing the dedicated Pandas Excel writer object, it acts a lot like a mechanical junction box. You can see exactly how it intelligently routes distinct data frames, DF1, DF2, DF3, into separate, specific named tabs like Sales and Inventory inside one single Excel workbook before it finally executes the save command.
Let's keep moving. Section 4, Bridging Storage and Publication, taking our data from databases all the way to visual PDFs. This visual perfectly captures the SQL Alchemy architecture. We are quite literally suspending a massive I/O bridge right between our active Python RAM on the left and our persistent database server hard drives on the right. Using Read SQL and TSQL, our data frames travel across this bridge, which allows us to query vast historical datasets without overloading our local application memory. To really master this bridge, though, you absolutely must understand the structural distinction between the engine and the connection. On the left, the engine is just the map. It simply defines the database dialect, like PostgreSQL or SQLite, and tells Python where it lives. But on the right, the connection is the actual live active socket transferring the data. You create the engine once, but you actively manage the connection for every specific I/O operation you perform. As we transition from raw storage over to publication, we obviously need to create visuals. Matplotlib allows us to route our figures into two completely distinct archiving paths. On the left, we can export to vector formats like PDF or SVG. This utilizes mathematical paths to give you infinite print resolution without any pixelation. Or on the right, we can choose raster formats like PNG, where we manually pass arguments like DPI equals 300 and transparent equals true to meticulously tune the fixed grid of pixels for super high density print quality reports. Now, to bundle all those visuals into a final report, the PDF kit generation pipeline acts as a literal compilation machine. It beautifully demonstrates how the internal WKHTML to PDF engine actually works. It can intake a live web URL, a structured local HTML file, or even just a raw string of HTML text you've generated dynamically in Python, process it through its internal gears, and churn out a highly polished final PDF document. Now, what's truly a game changer about these advanced PDF operations is this expert tip down at the bottom, the in-memory modifier. Normally, creating a PDF writes a physical file straight to your hard drive. But check this out. By passing the Boolean false instead of a target file name, you completely bypass the hard drive. The PDF is saved directly to your system RAM as a Python variable. That is absolutely ideal if you want to immediately attach that PDF to an automated email without leaving a bunch of junk files sitting on your disk. And finally, Section 5, the master pipeline, synthesizing our end-to-end automation. Look, whenever you face a new data challenge, just refer back to this master I/O diagnostic matrix. It removes all the guesswork by instantly mapping your target file format, whether it's a CSV, an SQL database, or an HTML table, with the single most optimized library and the exact required command. Notice how Pandas completely dominates tabular data, while native Python and NumPy hold down the fort for raw text and binary formats. And this all builds into our ultimate goal, synthesizing the entire process into a flawless 5-step end-to-end automated pipeline. We ingest raw web data using Pandas, read_HTML. We process and normalize it all in memory. We persist that clean dataset into a SQL database via SQL Alchemy. We visualize the analytics with Matplotlib. And finally, we publish the results bundled together using PDF Kit. And the best part, all of this can be executed instantly and repeatedly via a simple automated cron job. As you go off and build these systems, I want you to always remember these 3 golden rules of proper architecture. Number 1, rigidly match your engine to your state. Please don't use Pandas for raw binary. Number 2, always manage your memory by leveraging those context managers and NumPy compression techniques. And number 3, explicitly control and strip your metadata to ensure clean, frictionless downstream handoffs. I want to leave you with this final thought so you can go audit your own codebase today. Look really closely at your scripts and ask yourself, are you truly engineering a robust, structured data flow with the exact right architectural tools at every single phase? Or are you just moving files around and crossing your fingers hoping they don't break? Think about it. Thanks so much for watching this explainer, and happy architecting.